Welcome back to the POW-Master channel. In this video, we will show you how to use the display interface of the POW-SunSmart 6.5KP-PRO all-in-one solar inverter. First, let's look at the home page. It shows key data blocks for PV input, battery, inverter, grid input, UPS load, and generator. You will also see the power flow lights between them, which indicate the direction of electricity. From this diagram, you can quickly see whether the battery is charging or discharging and whether the grid is being used. You can also tap each block to view more detailed information. At the bottom of the screen, there are three main sections: Home, History, and Settings. Home is the page we are currently viewing. Next, let's look at the History menu. On the Today Data page, you can see the system's energy data for the current day. This mainly includes battery charging energy, battery discharging energy, solar generated energy, load consumption energy, mains charging energy, and load consumption energy from grid. The history page shows the energy records from the last 7 days. You can mainly review solar generation, battery charge and discharge energy, energy used from the grid, load consumption, and the load consumption from the grid. The energy statistic page shows the total accumulated energy data. For example, total battery charging energy, total battery discharging energy, total solar generated energy, total load consumption energy, mains charging energy, and total load consumption energy from grid. The historical fault page shows past system fault records. This helps users troubleshoot problems and maintain the system. Next, let's go to the Settings menu. This is the main configuration area of the inverter. Under Display Setup, you can configure the display options. Language allows you to set system language. Available languages include English, Italian, German, Spanish, Chinese, Polish, Vietnamese, and French. RS-485 address as the communication address of the inverter. The available range is 1 to 254. You can also set system date and time. Screen on time controls how long the screen stays on before turning off automatically. You can set it from 1 to 30 minutes. Screen always on keeps the screen on all the time. Beep enables or disables the audible alarm. Before changing this kind of setting, you need to enter a password. The default password is 4321. Backlight brightness adjusts the screen brightness from 1 to 100%. Restart LCD allows you to restart the display screen. In the password settings section, you can change the system password. You need to enter the new password twice to confirm the change. Next is Operation Mode settings. In the Word Mode section, Output voltage allows you to select the AC output voltage. Available options include 100 volts, 105 volts, 110 volts, 120 volts, and 127 volts. These options support different regional power standards. Output frequency can be set to 50 Hz or 60 Hz. Output mode setting defines the power supply priority. SOL mode or solar priority mode. Solar power supplies the load first. The grid will only be used when solar power is unavailable or when the battery voltage drops below the preset threshold. UTI mode, which means utility priority mode. In this mode, solar power supplies the load first. If solar power is not enough, the grid will assist the load. If solar power is sufficient, the extra energy can charge the battery. The battery only powers the load when the grid is unavailable. SBU mode or solar battery utility mode. Solar power still supplies the load first. When solar power is not enough, the battery will support the load. The grid will only be used when the battery reaches the preset load level. The SUB mode, Solar Priority Charge mode. In this mode, solar power prioritizes charging the battery, then it supports the load. If solar power is insufficient, solar and grid power can charge the battery together. At the same time, the grid supplies the load. Hybrid grid mode enables the city-based zero export function. When this feature is enabled, the inverter can supply power to home loads connected to the AC input line. At the same time, the city sensor monitors the power to ensure that no electricity is exported to the grid. Next is parallel mode. The setting defines how multiple inverters work together when they are connected in parallel. If you are using only one inverter, simply keep the default setting single. If multiple inverters are connected in a single-phase or split-phase system, all inverters should be set to parallel units. This allows the inverters to share the load and operate as one system. Now let's look at two-phase parallel systems. In this type of system, each inverter's L1 and L2 terminals are connected together to the same phase line, and the system has two phase lines in total. For this configuration, the inverter connected to the first phase line should be set to 2P0. The inverter connected to the second phase line can be set to 2P1 or 2P2. Depending on the phase angle you want. If you select the 2P1, the phase angle between the two phases will be 120 degrees and the system output will be 208 volts. If you select the 2P2, the phase angle will be 180 degrees and the system output will be 240 volts. Next is the three-phase parallel system. In the setup, each inverter is connected to one of three phase lines. The inverter connected to phase L1 should be set to 3P1, and the inverter connected to phase L2 should be set to 3P2. The inverter connected to phase L3 should be set to 3P3. With this configuration, the system provides 208 volt three-phase output. AC input range defines the acceptable grid input voltage. If you choose APL, the acceptable grid input voltage range is 85 to 140 volts. If you select the UPS, the acceptable voltage range is 90 to 140 volts. Grid type allows you to select a single-phase, split-phase, or two-phase system without neutral. Simply choose the option that matches the local power grid. The time charge and discharge feature allows users to schedule grid charging and battery discharging periods. You can set multiple time periods based on local peak and off-peak electricity prices. This helps reduce electricity costs. If you would like a detailed explanation of this feature or how to design a charge strategy, feel free to leave a comment below. Next, let's move to battery setup page. In the battery type section, battery charge current limit mode controls the maximum charging current of the battery. There are three possible sources for this limit. HMI setting means the charging current is limited by the value set on the inverter. BMS protocol means the charging current limit is defined by the battery management system or BMS. Inverter logic means the limit is controlled by the inverter's internal protection logic. BMS communication interface defines the communication port used for the battery. If the battery BMS uses RS-485 communication, select the RS-485. If the battery uses CAN communication, select the CAN. If there is no communication between the inverter and battery, select the Disable. Battery type is used to select the battery type. The inverter supports multiple lithium batteries and lead-acid batteries. You can also choose the user-defined to set custom battery parameters. Batteryless operation is also supported. BMS communication protocol defines the protocol used for communication between the inverter and battery BMS. The inverter supports multiple RS-485 and CAN protocols. Simply select the protocol that matches your battery BMS. Next is battery charging section. This section is mainly used to configure charging current, charging voltage, and SOC thresholds. Maximum charging current by grid sets the maximum charging current when charging the battery from the grid. This value refers to the battery charging current, not the current on the AC input side. It is also not affected by the time charge or discharge schedule. Maximum charging current sets the maximum charging current during the constant voltage charging stage. Maximum charging voltage sets the maximum charging voltage during the constant voltage stage. Battery charging current stop charging is setting works during the constant voltage charging stage. When the charging current drops below this value, charging will stop. If the inverter is communicating with the battery BMS, the setting usually does not need an adjustment. Battery SOC stop charging. This setting works only when BMS communication is active. When the battery SOC reaches this value, the battery will stop charging. Battery recharging voltage. This setting defines the voltage level that restarts charging after the battery is fully charged. If the BMS communication is working normally, this parameter does not need to be set manually. The system will automatically restart charging when the SOC drops 5% below the battery SOC stop charging value. Charging mode. This setting defines how the battery is charged. Hybrid mode means the battery can be charged by both solar power and grid power. PV only means the battery is charged only by solar power and grid will never charge the battery. Next is battery discharging section. This section is used to configure battery discharge protection. It includes settings for voltage thresholds, SOC thresholds, current limits, and delay times. This four settings only applies when hybrid grid mode is enabled. Battery voltage stop discharging in hybrid. When the battery voltage drops below this value, the inverter will stop battery discharging. Battery SOC stop discharging in hybrid. When the battery SOC drops below this value, the system will stop battery discharging. Battery voltage restart discharging. When the battery voltage rises above this value, battery discharging will resume. Battery SOC restart discharging. When the battery SOC rises above this value, battery discharging will also resume. Battery under voltage alarm. When the battery voltage drops below this value, the inverter will trigger a low voltage warning. However, the battery will continue discharging. This parameter is only used when there is no BMS communication. Battery under capacity alarm. The setting works when BMS communication is active. It works the same way as a low voltage alarm, but it uses battery SOC instead of voltage. When the battery SOC drops below this value, the inverter will trigger a low battery warning. The alarm will remain active until the SOC rises 5% above this value. This warning does not stop discharging. Battery voltage low recovery. When a low voltage alarm occurs, this setting defines the voltage level required to clear the alarm. Battery SOC low fault. When the battery SOC drops below this value, the inverter will report a low SOC fault and stop battery discharging. Battery voltage low fault. When the battery voltage drops below this value, the inverter will report a low voltage fault and immediately stop discharging. Battery voltage low delay. This setting defines the delay time before discharging stops. When the battery voltage or SOC reaches the stop threshold, the inverter will continue discharging for the configured delay time before stopping. Battery maximum current discharging. This parameter defines the maximum battery discharging current. You may notice that most charging and discharging thresholds have two versions. One is based on battery voltage and the other is based on the battery SOC. Voltage-based thresholds are used when there is no BMS communication or when communication fails. SOC-based thresholds are used when BMS communication is active. In an advanced setup, there are several additional features. PN connected enable controls the connection between the protective earth and neutral. This may be required by certain grounding systems or local electrical standards. Power saving mode reduces standby power consumption. If the load is below 25 watts for 5 minutes, the inverter output will turn off automatically. When the load rises above 40 watts, the output will restart. Diesel charging current is used to set maximum charging current when a diesel generator is charging the battery. The adjustable range is from 0 to 80 amps. This setting helps protect the generator from overload while also controlling the charging speed. Diesel rated power allows you to define the rated power of the connected diesel generator with a range from 0 to 10 kilowatts. By setting this parameter, the system can better understand the generator's supply capacity, enabling smarter load distribution during parallel operation or switching, and preventing generator overload. External CD ratio is used to configure the current transformer ratio. The correct value should be based on the specifications labeled on the CD. For example, a CD marked at 300 amp/150 milliamp means the primary current is 300 amps and the secondary current is 150 milliamps. The ratio is calculated by dividing the primary current by the secondary current. So in this case, the setting should be 2000. Zero export power mainly functions in hybrid grid mode, when the system supplies excess energy to home loads instead of exploring it to the grid. This parameter defines the allowable margin for small management errors or power fluctuations. The Restart Inverter section allows you to either restore the inverter to factory settings or simply reboot the device. The Wi-Fi setup section is used to connect the inverter to wireless network. After installing the Wi-Fi antenna, you can search for and connect to available network on this page. Please make sure to use a 2.4 GHz Wi-Fi network. Once connected, you can conveniently upgrade the system via the Update LCD firmware option. That's the full overview of the POW-SunSmart 6.5KP-PRO display interface. If you have any questions, feel free to leave a comment below. Thanks for watching, and we will see you in the next video.